Okay, ladies and gentlemen, very good afternoon to you all. Thanks for being here. We're going into a very interesting field of hacking, actually hacking people. Well, how should I say, fixing people rather. We're talking about prosthetics. Now, prosthetics is when you crash your bike and you lose your leg and you get another technical one. That's the typical use of prosthetics in the West. There are other countries, war-torn countries, countries with a lot of natural disasters, developing countries where basic health care is not at Western standards. These people have health problems with diabetes, gangrenes, infections. In war-torn zones, we all know the stories about landmines. And there are other areas where, due to massive natural disasters, landslides, earthquakes, people get wounded. People have to cut their legs off, their arms off, and unless here, where we've got health insurance that at least pays you a basic prosthetic implement at the cost of some 2,000 euros, maybe. They don't have health insurance. They don't have the money to buy these expensive implements that we've got. We've been working together here at Amsterdam Fablab with a group in Yogyakarta. HONF, they're called. HONF is an abbreviation for the House of Natural Fiber. The House of Natural Fiber came to us to learn about prosthetics. Because, you know, here we do, we create these implements at costs of 50,000 or even 200,000 euros per piece. They wanted to know how do we do that, and they wanted to find a way how they could implement making prosthetic implements there in Indonesia at a very much lower price. But first, of course, they had to understand what our high-tech implements are all about. And this is a short film, and I would now need the audio of the laptop, please. Avi, alsjeblieft, kan ik even... Hey, kan ik even het geluid van mijn laptop hebben? Dankjewel. This is a promo film of a modern high-tech arm implement controlled by the nerves through electronics. I suspect that the whole film is some kind of clever animation. That's where technicians and biomedics want to be in a couple of years' time. But technically, this kind of thing is certainly doable.
The world's fastest, most powerful body upgrade.
To just show you where we are at the moment, a very short clip from Touch Bionics with a guy actually using an implement that he controls with the nerves that are still living in his arm.
Yeah, since sitting here with this limb, it is really like being reborn, you know, but even seeing it, and it's a big learning curve again, because the learning curve for me was learning to walk and learning to use just normal, you know, standard fitting limbs, but this is something incredibly special. And at the age of 53, I think that's pretty good, I think. My kids will be in awe. I mean, everyone around the road will want to come and see me. I mean, it won't be a freak show because I just think that's fantastic. I do. And I think if I can master this, I'll be able to cut my food up.
Right, so that's the real thing. That's technology we can deploy in the West. And here you see a number of other pictures of how these implements are actually tested and used in a lab. That's obviously the parts of these implements. You see joints, you see all types of pretty high-tech, high-quality stainless steel things. Here you see a number of foots for walking, foots for running. You've certainly seen pictures of these legs. They come at a pretty high price, 10,000 euros, one of them. Here you see them as we were playing around with these implements at our lab. Very different story. We moved to India. In India, there is a company, Jaipur Foot, and they produce lower leg protheses at a much lower cost. They are able to reduce the cost to something.
Just of the leaflet pressure are marked, then the soaked POP bandage is wrapped around the stump. The anterior and lateral alignment axes are marked. The negative cast is removed from the stump. This cast is fixed on a wall frame and the mandrel is put in the center of the cast in reference to the alignment axis. The alignment of this cast is reconfirmed by the laser line system. Then this negative cast is filled with the plaster of Paris paste. The wall frame is obtained from Endolite, a British company, and the laser alignment system is from Ottobock, a German company. To get the best alignment, BMVSS has married these two different systems. As the POP paste solidifies, the negative cast is cut open and a positive mold is thus obtained. This is modified as per the markings, which are marked at the time of taking the measurement, and is given the exact shape of the stump of the amputees. This modified positive cast is then fixed on a vacuum forming machine. This is then covered with a heated EVA sheet, which is formed by vacuum to get an exact fitting soft insert. Now this positive cast, covered with EVA soft insert, is again placed over the vacuum forming machine. This is now draped with a heated HDPE sheet, which is again vacuum formed to get the exact shape of the stump, providing excellent stump socket interface. BMVSS has imported the total vacuum forming system from Germany to get closest fitting sockets. This HDPE covered positive mold is again fixed on an alignment apparatus and it is extended into a full prosthesis size. This extended positive mold is again brought into the draping room and is fixed over a vise. A HDPE pipe of the skin color is heated in an oven, and when it is sufficiently malleable, it is sleeved over this extended mold. The plaster is then removed, and the extra material from this limb is also removed. A Jaipur foot and a belt is then fitted to it. This prosthesis is then worn by the patient and the height of the prosthesis is checked. The prosthesis is then checked on a static alignment apparatus and is then given to the patient. The gait of the patient is checked. If any correction is to be done, it is done at this stage.
So that's how they do it in India, and such a foot costs around $500. That's still about 1.5 times the annual income of these guys in Yogyakarta. So to really be able to produce these kind of implements there, there is another cost reduction needed, and that's what these guys from HONF are aiming at. You see, they are